because I've noticed a really big mistake where I've put this if statement in and then I've got elifs. I've actually done it on the wrong line. These ones here should be elifs and these should just all fall under this same if. So basically if I make all of these elifs, then I should just be able to delete these lines. Not that one needs to stay. So basically we check if the position we're at is a end, and then we just check all the left, up, right, down moves. We don't need to keep the elif in, because what the elif was doing was basically it would hit this if because it would be an end, and then it would check if it was right, a right move was available, and then because this was an if and then there was elifs here, it would then not hit all the elifs. So basically we were only moving right, and it was breaking the left and right moves. So that should fix that. Now the next thing I've done is I've started setting up what it's going to return. So board to return numpy.zeros, it's going to be size of board. We want to return the board as it came in, so like a 5x5, we don't want to return all these x's. So basically all this does is create a 5x5 board, or like a board that's the size of the input one that was the size of board. It loops through it and it replaces every cell with, or every element, sorry, with the corresponding element in the solve board with X, or the board with X that now should be updated, and it returns that. So that's what I've done down there. Now up here I've been working on a separate loop to check for any lone ends. So it checks for each colour, it loops through the colours, and it says the colour count is equal to 0. Then it goes through another loop, this time for K and L, because obviously we're within the IJ loop, so we can't use I and J here. So for K and L, in the bounds of the board, if the colour is equal to the position we're at, then the colour count goes up by 1. We've just found one end of that colour. Then it keeps going for all the others. Now when it's finished that, it says if the colour count is only 1, so we only found one end of that colour, we know that we need to go and capitalise that end, so we loop through again and go find it, and then when we find it we capitalise. So that should solve our green ends being next to each other problem. So I'm going to save this and then we'll run it and we'll see. Okay, so I've solved the left problem, the blues are now working properly, and as you can see one of the greens definitely got capitalised. It wasn't the one I was expecting though, so I'm going to have to go back and see why this happened. It could have been something to do with these oranges seem to have blocked it off, so that might be why. Maybe when we, oh, one more thing I added, I called the function again, so now it runs twice. So you'll see the first pass, this is what we got, and then the second pass, this is what we got. So it seems like it's a little buggy because this second pass doesn't seem to have done anything. So yeah, I'll crack on with this, see how far I can get, see where these bugs are, be back and show you how I did it. Okay, I was actually wrong there, it has done something on the second pass. The first pass for the blues, if we look at the blues, the first pass it moved left, and then the second pass, this was the input board, so obviously you're going to expect these two to be the same, and then the second pass it went up, so it definitely did do something. I was just looking over here and I didn't see as much as I was expecting, so yeah, it seems okay. I'm just going to check with another loop now. If we call it again, I want to see if the other end of the green gets capitalised, see what happens to the blue, see if the blue continues going up. So we see the green hasn't been capitalised, so we've got some problem here. I'm gonna have to see what this is, but the blue did keep going up, so that's good. I'd expect if we keep calling this, we'll end up with all the ends together. So you can see we've filled the board here, we've got, we've just got one end left for each one. This is the orange end. So it does look like it's found a solution. If we draw out the solution, we'll be able to see. So blue we expect to, oops, and then green goes there. So we expect green to go along this bottom, it did. We expect blue to go all the side, it did. We expect red to go all the way up and across, and it did. We expect yellow to go up and across, and it did. And then orange to fill in the gaps, and it did. It seems to be working fine, except for this capitalization problem, so I'll check what this is now, and I'll be back once I figure it out. Because I figured out the mistake, it was just here I'd put, it's not here, it was here, I'd just put this part of the line, I'd forgot to actually set it equal, like set the element equal to the capitalization of the element. All I'd done is just take the element and capitalize it, but not actually put it back in the matrix. So fix that. Then I've changed these ranges because they don't need to be, they were previously 1 to the size of the board plus 1. What we can do instead is just do them in the size of the board and then just add plus 1s here to change where we're working with. So all these plus 1s are added in. So you'll see now in this output over here, you can see the green does get capitalized, so our green line is now finished. So if I uncomment this over here, you should see that we get a full solve board. Not quite like that. Okay, it seems to have broke differently. Why have we now got loads of zeros? Red seems to be going over the blue now. Interesting. Okay, it looks like I'll be back soon. Okay, so thanks to a lot of print statements, I've figured out the mistake. So this right here was I and J, and obviously it's not I and J that we're going to be using in this loop, it's going to be K and L. So change this to K and L, then save, and then when we run, see we get the full board printed out, all solved, all capitalized. So this is definitely a good result. Use this to hopefully set up some other algorithm to start like outputting this as mouse movements and start drawing the board. So I'm just going to delete these prints that we no longer need. Okay, so next step is to fix this. So we want it to loop until the board's solved, basically, or the board stops changing would be a better way of putting it. So in case this method can't solve it, it would just output the best, the furthest it gets. So I'm going to quickly look up how you can check if a matrix, or sorry, an array is equal to another array, and then I'll be back. Okay, so now I've found the correct syntax for equal, so it's this right here, so numpy.array underscore equal. This checks if two arrays, so you pass it two arguments, are equal to each other, and it returns a boolean, so like a true or false. So because it's going to check if they're equal, and we want if they're not equal, just stick a not in there. Then this loop works fine. So I've added some print statements so you can see the output at each step of the way. So what's going to happen is comes into solve board, prints a new line, prints the unsolved board, prints a new line. Then it's going to attempt to solve the board using the false move check algorithm we've just went through. And in doing all this, I've removed all the print statements from this now because we no longer need to mess around with this. So it's going to try and do that. Return unsolved board, it'll print the new unsolved board. Now it'll check if the new unsolved board is different to the original board that we came in with, so this thing right here. Now if they're different, it'll try again. So it's going to start back from up here and go through again the exact same thing. If they're not different, then it's going to continue and it'll do whatever our next function is. We're not going to be writing this for quite a while yet, but this is where we can like expand in the future and try and find other algorithms to help solve this, so maybe methods aren't as robust as this. Then it's going to return the unsolved board at the end. So what you'll see when I run this So you can see it actually doesn't have the X border anymore, because we don't return the X's out of this function down here. These are only used in this function, so that's good. Then for the rest of the board, you can see it's generally updating like every 2 boards, I think it updates or something. But you'll see towards the end the final solution gets printed out 3 times. That's because it goes through this function which solves it the first time. So this is now a fully solved board. It then prints the fully solved board. It checks the whether the boards are equal, and now the fully solved board is not the same as the board that came in, because the board that came in was 1 move away from being solved. So it runs the function again. Now this board is now fully solved. It's going to print it again, so this is our second print. It's then going to run the algorithm on it again to try and solve it, since it doesn't think it's solved yet. It's then going to print it again, so this is our third print, and now it's finally going to realise we've actually got a solved board now, or at least a board that can get as solved as possible using only our forced move check algorithm. Then it moves on. So we are wasting a slight bit of processing here, but it's nothing to worry about. It's fast enough that it's not going to matter, and it just saves having to mess around with this. So that's all for now. Next video we're going to look at how to draw this to the screen. So how to take this matrix here and actually control it using probably PyAuto GUI, and trying to drag the right lines to the right shape of the board using probably drag move, I think would work. Maybe just click and move, something like that. We'll see. I'll have a mess around with it. But yeah, that's all for now. Thanks for watching, and I'll see you in the next video.